So guys, welcome back. In this module, we will going to study about application state synchronization. So what is application state synchronization? Application state synchronization means syncing the application state to another machine which is called redundant machine, and that redundant machine is running redundant backup instance of the application, right? So application state means the snapshot of all data structures kept in the memory, right? So of course you have an application, and application may have various data structures which are kept in the memory. So the snapshot of all those data structures at any point of time is called application state. So that application state comprises of all the data structures which is kept in the heap memory of the application. So any memory which your application creates using malloc system call, all that memory is allocated from the heap, right? So all dynamic memory allocation that your application does is allocated in the heap region. And then your application may have global variables. Now global variables are not a part of heap region, but they contribute to the application state. So both the heap memory, that is dynamic memory, and the global variables of your application, both together comprises the application state. So what is application state? All the data structures which is kept in the heap memory and all the data structures which is kept in the global variables forms the application state. So application state keeps on changing. As you know, your application may have linked lists, trees, queues, stacks in the memory, right? And as your application executes the logic, of course your data structures which is kept in the memory keeps on updating with every instruction. You can delete some data structures, you can add new data structures, or you can update the existing ones, right? So these are the normal operations which is performed by your application at the execution of almost each instruction. So it is desirable for application which needs to be up and running 24/7. So there are certain applications which are actually critical and they needs to be up and running 24/7, right? And for such applications we would want zero downtime. That is, we would not want those applications to fail for any reason. So it is for this reason that it is desirable that for such applications we also need to have a backup instance running on alternate machine, right? So in case the primary machine fails for any reason, now the reason could be anything. It could be machine failure, it could be power failure, it could be hardware failure, it could be software failure, or any other failure, right? If the primary machine fails for any reason, the backup machine or the backup instance of the application should take over and continue to provide the application service, right? So let us try to understand this point with the help of an example. So for example, suppose you have a network equipment such as router. If router fails, then it may disrupt many network users, right? So router disrupt many network users when they go down. So it is desirable to have a backup router, that is another router which is used as a backup, which takes over the primary router almost instantly when the primary router goes down. Backup equipment must resume from the same state. Note the word, this is the key point. The backup equipment must resume its functioning from the same state where the primary equipment failed. Now here same state means that when the backup equipment resumed the role of primary equipment, then the application state of the backup application must be exactly same as the application state of the primary application at the time of failure. So let us try to understand the concept of state synchronization with the help of an animation. So you can see that here the router R1 is actually a primary router and the router R2 is actually a backup router, and they can communicate with each other over the network. So obviously router R1 will be running many routing protocols, and those routing protocols will have their application state, right? Maybe those routing protocols are maintaining routing tables. Those routing protocols may be maintaining the information regarding rest of the network topology, or it could be anything, right? So this diagram is the representation of application state of an application running on router R1. And that application provides the service to these end users, which is represented by these good looking laptops. Now router R2 is running the same application which is running on router R1, but that application is running in the standby mode, right? And that application maintains the application state, which is exactly the clone copy of the application state of the application running on router R1. Now the question is, the application which is running on redundant router R2, how can this application make sure that its data structure is actually the clone copy of application state of the application running on router R1? Well, this is actually achieved by periodic synchronization of application state from primary application to redundant application. So the application running on primary router R1 can choose to periodically synchronize all its data structures, and it can choose to do this synchronization periodically. So when the redundant application running on redundant router R2 receives the synchronization data from the application running on primary router R1, router R2 can flush off its old application state, and from the synchronized data that it has just received, it can reconstruct the new application state, right? So this way, the redundant application running on redundant router R2 can ensure that its application state is up to date with the application state of the application running on router R1. Now, as we discussed that the primary router R1 is actually the router which is providing services to these end users. So you can see that these arrows actually represent the service that is provided by the router R1 to these end users, right? So this is actually the traffic that is flowing from the router R1, and the L2 switch is distributing this data to the end users. Now suppose that the router R1 fails, right? So the end users will stop receiving the traffic. And remember that these end users could be hundreds of users in number. So you would not want your hundreds of users get impacted because of failure of one machine, right? So the router R2 should have a mechanism to detect that the primary router has failed, and as soon as the redundant router detects that the primary router has failed, it takes up the responsibility and takes over the role of primary router, meaning that the redundant router now plays the role of primary router. So you can see that in this case, the redundant router R2 has taken the role of primary router and starts sending the traffic, right? So you can see that the end users will continue to receive the traffic, or in other words, the end users will continue to receive the service from the router R2. So the end goal of this entire state synchronization is that the redundant router R2 should instantly resume from the same point of failure of R1, right? And the goal of this state synchronization is to provide non-disruptive service to the end users. So from the end user's point of view, end users would not even know that the router R1 has failed, and the redundant router R2 has taken over the responsibility of the primary router R1, right? From the end user's point of view, they would not even know this thing, and they will continue to receive the non-disruptive service from either router R1 or router R2 as the case may be.